Okay, next sum number 2. Find the total resistance in the circuit. The circuit that is given to us. Okay, this is 7.2 ohms. Now here 8 ohms and 12 ohms, both of these are in parallel to each other. Okay. So now first I'm going to take these 8 ohms and 12 ohms, I'm going to find the parallel resistance. So I'm going to use the formula for parallel. 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. This will give me 1 upon 8 plus 1 upon 12. Okay. Now 12 and 8, the LCM is 24. 8 3s are 24. 12 2s are 24. So this gives me 5. 3 plus 2 is 5 divided by 24. That is 1 upon Rp. So Rp is reciprocal of that. That is 24 divided by 5. That is going to become 4.8 ohms. Now this is not your final answer. You have just found the resistance of parallel. Okay, this is the parallel resistance that you have found out, which is 4.8. Now this is in series with 7.2. So the total resistance of the circuit is going to be this Rp plus that series resistance which is there. Okay, I'll take this as R4. So this is going to become 4.8 plus 7.2. If you add this, it's going to become 12 ohms. Okay, this is the total resistance of the circuit. This is your final answer. Now sum number 3. Find the total resistance and the current in the circuit. Now see, here we are having the resistance of 5 ohms. These 3 ohms and 2 ohms are in series. They are one after the other. So I can directly add them. This will become 3 plus 2. So this is also going to become 5 ohms. Okay, instead of 3 ohm resistance and 2 ohm resistance, I can replace it with one resistance which is having how much value? 5 ohms, because 3 plus 2 is 5 and they are in series. Now this 5 ohms and this 5 ohms, both of them are in parallel. So I can find the resistance by using the formula for parallel. Alright, so we will just find that parallel resistance. Okay, this has given me 5 ohms, and this 5 ohms and this 5 ohms, we are going to find it in parallel. So I'm going to use the formula for parallel. 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. This is equal to 1 upon 5 plus 1 upon 5. This is going to become, okay, 5 is the LCM. I'm going to get here in the numerator 1 plus 1. That will be 2 divided by 5. This is 1 upon Rp. Okay. So Rp is going to become reciprocal, that is 5 upon 2, which is going to become 2.5 ohms. This is the total resistance of the circuit. One more thing that we are asked to find is how much is the total current. Now here the voltage of the battery or EMF of the battery is given, which is 4 volts. And the total resistance of the circuit we have just found out, it is 2.5 ohms. So I'm directly going to use the formula for Ohm's law. Ohm's law formula is V is equal to IR, or I into R. I'm supposed to find the current, so V divided by R will give me I, that is the current. Voltage is 4 volts. The resistance we have found out, it is 2.5 ohms. This is going to become 40 divided by 25. If I shift the decimals, 5 8s are 5 5s are 8 upon 5. If you divide this current is going to be 1.6 amperes. Now sum number 4. If two resistors are connected in series, the total resistance is 45 ohms. And if the same resistors are connected in parallel, the total resistance becomes 10 ohms. Find the value of individual resistors. Okay, now two resistors in series give us 45 ohms and in parallel give us 10 ohms. Okay, so I will take, let the resistances be X and Y. So first is in series. Correct, in series it is addition of resistances that gives the total resistance. So X plus Y, this gives me 45. Okay, the total resistance in series they have given 45 ohms. Then in parallel, okay, the resistance value given is 10 ohms. That is Rp is 10 ohms. I'll apply the formula of Rp, 1 upon Rp is equal to 1 upon R1 and 1 upon R2, which is going to be 1 upon X plus 1 upon Y. Okay, so this is going to give me 1 upon 10 is equal to XY is the LCM. In the numerator, I'm going to get over here X plus Y. Okay, so this is going to give me, I'll just cross multiply this. This will come over here. This will come over here. So XY is equal to 10. Now you know X plus Y is 45. So directly I can write 45 over here. Okay. Now for solving this, I can write Y is equal to, if I bring this X over here, it is going to become 45 minus X. So here X will remain X only. Y will become 45 minus X. This is equal to, if I multiply this, this becomes 450. I'll just open this bracket. 45x minus x square is equal to 450. Okay. So this becomes, bring all terms on one side, x square minus 45x plus 450 is equal to 0. So we are going to factorize this quadratic equation. 450 factors. The factors are going to be minus 30 and minus 15. Okay. So this is going to become x minus 30 into x minus 15 is equal to 0. X is equal to 30 or x is equal to 15. If x is 30, then y is 15. If x is 15, then y is 30. Therefore, the two resistances are 30 ohms and 50 ohms. Okay. Two resistances are 30 ohms and 15 ohms. Now, sum number 5. If a bulb of 60 watts is connected across a source of 220 volts, find the current drawn by it. Okay, now what is given over here is power is 60 watts. The voltage that is given over here is 220 volts. What we are supposed to find over here is the current, that is I. The formula is straightforward, very simple. Power is equal to V into I or VI. Power is 60 watts is equal to, the voltage is 220 volts multiplied by I. So 60 divided by 220 will give VI, that will be the value of current. 2 3s are 2 11s are. If you divide this, this is going to give me 0.27 amperes. Of course, this number is recurring, it will go 0.272727. Okay, but we have rounded up up to second decimal place. Now sum number 6. A potential difference of 250 volts is applied across a resistance 1000 ohms in an electric iron. Find the current and the heat energy produced in joules in 12 seconds. Okay, now the potential difference is given. That is the first thing. That is 250 volts. The second thing that is given is the resistance, that is 1000 ohms. We are supposed to find the current and the energy produced in joules in 12 seconds. So current, that is I, is supposed to be found, and we are supposed to find out the energy produced, that is heat energy produced in joules in the time 12 seconds. Okay, now here V is given, R is given, I we are supposed to find. What is the simplest thing that we can do? Ohm's law. That's V is equal to IR. Correct. So V divided by R will give me I. V is 250 volts. Resistance is 1000 ohms is equal to the current I. If I divide this is going to give me the value of 0.25 amperes. The second thing that we are supposed to find is the amount of heat energy produced in the time 12 seconds. Okay, this is equal to, the heat energy is given by the formula. Straight formula is there, VIT. V is there, that is 250 multiplied by the current you have just now found, 0.25, which can be written as 25 upon 100, multiplied by the time given is 12 seconds. 25 ones are 25 fours are 4 threes are 12. 250 multiplied by 3 is 750. Its answer is going to be in joules. Now sum number 7. A washing machine rated 300 watts is operated for 1 hour per day. If the cost of unit is rupees 3, find the cost of energy to operate a washing machine for the month of March. Okay. Now first of all, what is given over here is the power is 300 watts. Okay, whenever we are calculating the cost of electricity, this power always has to be in kilowatt. Okay, so this has to be 300 divided by 1000. Watts is going to become kilowatts. Alright, now it is used for 1 hour per day, and you are in the month of March. So month of March is having 31 days. So 1 hour per day it is used, it means it is used for 31 hours. Okay, so the time for which this is used is 31 hours. Alright, the electrical energy units will always be calculated in kilowatt hour. So the energy that is calculated, the formula is power multiplied by time. Here the power should be in kilowatts, which is 3 upon 10, multiplied by this time should be in hours, which is 31 hours, is used for month of March. Okay, if I do this calculation, this is going to give me 9.3 kilowatt hour or 9.3 units. Now the cost of electricity, cost of unit is 3 rupees. So the total amount incurred or total rate, total cost that is incurred is going to be the energy multiplied by the rate, which is going to become energy is 9.3 kilowatt hour or 9.3 units multiplied by the rate is rupees 3 per unit. If we multiply, this is going to be 27.9 rupees. Now sum number 8. If a TV of rating 100 watts is operated for 6 hours per day, find the number of units consumed in any leap year. Okay. Now the first thing that is given to over here is power is 100 watts. Okay, obviously we are calculating electrical units, so it has to be in kilowatts. So 100 divided by 1000. Whenever you are converting watts into kilowatts, you are supposed to divide by 1000. Okay. The next thing is here, it's operated for 6 hours in any leap year. Leap year will have 366 days and every day it is used for 6 hours. So the time for which it is used is 366 days multiplied by 6 hours per day. This is going to give me 2196 hours. Okay, so in 1 year the TV is used for this much time. Now we are supposed to calculate the energy units. This energy units is going to be power multiplied by time. This is going to be, the power is 1 upon 10 multiplied by the time is 2196 hours. If you multiply this, this is going to become 219.6 because basically 1 upon 10 is 0.1. When you multiply this with 2196 is going to become 219.6 units or kilowatt hour. Now ninth sum. How will you connect 3 resistances of 4 ohms each to get 12 ohms, 6 ohms and 4 upon 3 ohms respectively? Okay, we are given 3 resistances. R1 is 4 ohms, R2 is 4 ohms and even R3 is 4 ohms. 3 resistances, each one of them are 4 ohms each. Now we are supposed to connect them in such a way so that we get 12 ohms. This will be the first part. In the second part, we have to connect it in such a way so that we are getting 6 ohms resistance. And the third way in which we are supposed to connect is we are supposed to get 4 upon 3 ohms. So there are 3 different parts in the same sum. Obviously, the first part is very simple to understand. There are 3 resistances, 4, 4 and 4. Okay, and I'm supposed to get the total resistance of 12 ohms. So obviously here all 3 of them will be connected in series. So the first part is RS is equal to R1 plus R2 plus R3, which is going to be equal to 4 plus 4 plus 4, which is going to become 12 ohms. You may be asked sometimes even to draw the diagram for this. So you can simply draw the diagram. All 3 of them are connected in series. So 4 ohms, 4 ohms, 4 ohms. Now the second part. We are supposed to get the effective resistance of 6 ohms. Obviously this value is more than 4. So 2 of the resistances we will connect in parallel and 1 resistance we will connect in series. So here it is going to be 4 plus whatever the parallel of these both we are getting. Correct? So this is going to be first R1 and R2 in parallel. So I'm going to get the formula for RP, that is 1 upon R1 plus 1 upon R2. That is 1 upon 4 plus 1 upon 4. This is going to become 4 is the LCM, 1 plus 1 That's 2 upon 4. That is 1 upon 2. This is 1 upon Rp. So your resistance in parallel is 2 ohms. Now the third resistance that is remaining, that will be connected in series. So that is going to become R3 plus Rp, because we have connected these both in series. This is going to become 4 plus 2, that is 6 ohms. This is how we are supposed to get it. We can also show this with the help of a diagram. Two resistances are connected in parallel, and the third resistance is connected in series. So this will be R1, that will be 4 ohms, R2, that will be 4 ohms, and R3 is connected here, that is 4 ohms. So this 4 and 4 gives me 2 ohms, and this 2 plus 4 gives me total 6 ohms. The last of this is we are supposed to connect this in such a way so that I'm getting the effective resistance of 4 upon 3 ohms. Okay, we are supposed to get the effective resistance of 4 upon 3 ohms. Now this 4 upon 3 means nearly 1.33. Correct? All three resistances R1, R2, R3. These are 4 ohms. Now 4 upon 3 means 1.33. This value is less than each one of these resistances. And this way you can get only if you connect all three of them in parallel. So obviously 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This will be 1 upon 4 plus 1 upon 4 plus 1 upon 4. This will be 4 is the LCM, 1 plus 1 plus 1. That is 3 upon 4, 1 upon Rp. So Rp is 4 upon 3. That is going to be the required answer. Now this also you can show this with the help of a diagram. Here obviously all three resistances are connected in parallel. So the connections will be like this. Okay, when you connect all the resistances in parallel, then the answer that you get, it should be less than each one of these values. Okay, 4 upon 3, if you calculate, it is going to be 1.33. And this value is less than 4, 4 and 4.